2.1, number 1. So this is the approximating and guess scheme. And what are we approximating and guessing? We are approximating and guessing the slope in this problem of f of x equals x squared plus 1 at x equals 1. Now, the reason I know it's at x equals 1 is because they tell us that p, this point on the curve, is 1, 2. They've defined for us which point we want to work with. And we also see that in their table, they have x values which are getting closer and closer to 1. In particular, I'm not going to write the fourth one. In particular, x is heading towards 1 from the right, apparently, right? This is a little bigger than 1, not so much bigger than 1, and even not so much bigger than 1, right? Getting closer to 1 from the right. They've got corresponding y values that we're supposed to compute. So putting 1.1 into the function here, right, f of 1.1 will be 1.21 plus 1, 2.21. Let's do the calculations very quickly here. 2.1. This is pretty obvious. 2.0201 and 2.002001. Again, that's after you've run these numbers through the entirety of the function, right? And then it has qxy, which are just these coordinates set up as points. So here's a point on the curve. This point is close. Oops, sorry. This point is close to P, but this point is not as close to P as the next one is. 01, 2.0201, and that one's not even as close as this one. And you could keep moving further and further if you wanted. Again, I didn't do the fourth coordinate. This will be fine for our purposes. 0, 0, 2, 0, 0, 1. And then the final thing in the table they have is what they have a notation for msec, the secant slope. So what we're doing here for this secant slope, m secant, is going to be, like we saw a minute ago, f of x minus f of a over x minus a. Now in this case, a and f of a are these, right? This is a comma f of a. It's 1 comma 2. So I'm just going to fill those in. So now we have f of x minus 2 over x minus 1. Right? And now we're just filling in for each of these rows in the table. I'm going to use q as the second point to work with. So x and y here are going to be 1.1 and 2.21 respectively. Okay, so when x is equal to 1.1, the secant slope is going to be the y coordinate here, 2.21 minus 2. I'm just filling in f of x here with this f of x coordinate, and then x here, I'm filling in with this x coordinate, 1.1 minus 1. So let's see what we get. We get 0.21 over 0.1, and that says shift the decimal one place to the right, therefore we get 2.1. All right, so 2.1 is the slope of the secant line connecting this point here with the one they chose, 1 comma 2, where we're supposed to be approximating our tangent slope. Let's continue quickly through x equals 1.01. 1.01. So m secant slope there will be 2.0201 minus 2 again over 1.01 minus 1. So of course we will get 0.0201 over 0.01, shifting the decimal 2 places to the right, which is what this indicates. We will have 2.01. The pattern is already getting pretty clear. And again, what does this pattern represent? It represents slope of the secant line, 2.1, as the point on the curve. That's to the right of this one. It gets closer to this one. The secant slopes become more and more like the slope of the tangent at 1, 2. Okay. Compute the third one. X equals 1.001. So the secant slope for that coordinate will be more than likely 2.001. Let's just check it to make sure. So 1.002001 over 0.001, shooting 3 places to the right. We have 2.001, just as we guessed. So it looks very much like if this trend were to continue, right? As the x's get closer and closer to 1, right? The secant slopes get closer and closer to 2 would be our guess. So 2 is going to be the guess of the what? Of the slope of the tangent line to f of x at x equals 1. And again, always keep in mind, what does that mean? i.e. the slope of the curve at x equals 1. That's our guess.